What's up everyone, I'm Saya Pahati, a grade 11 STEM from Wilson College Rizal Incorporated, and today I'm going to be showing you an example for finding the resultant force of concurrent coplanar system of forces. So without further ado, let's get right into the video. So now what we have here is four forces that are same to act at one single point. We can call that point O. And we see 100 newtons force at 45 degrees from the horizontal. This is the x-axis and this is the y-axis. 80 newtons at 30 degrees from the negative x side. Then 70 newtons at 30 degrees and 60 newtons at 50 degrees. The forces which we have here can be resolved into x component and a y component. So for example, the 100 newtons force can be replaced with a force going towards the right, where its magnitude will become 100 in cosine 45, and a y component which will become 100 sine 45. Same goes with the 80 newtons. A component from the x direction which would become 80 cosine 30, and a component for the y direction which would become 80 sine 30. Then an x component for the 70 newtons which would become 70 cosine 30, and a y component for the 70 newtons, which would become 70 sine 30. 60 newtons can be resolved with the y component going downwards, so it will be 60 sine 50, and an x component which will become 60 cosine 50. Now, the first step for finding the resultant is to find the components of each force. And we can see the x component for each vector and the y component for each vector. We'll go through tabular method for finding the resultant. And so we'll construct a table. In this table, we'll have the description, then we'll have the x component and also the y component. The description would be the four forces we have. So our first force was at 100 newtons that was acting at an angle of 45 degrees as measured from the x-axis. We also have 80 newtons force which was acting at an angle of 150 degrees. So as you can see here, the angle measurement from here to this point will be 150 degrees. So now we write 150 degrees. Then we have the 70 newtons acting at an angle of, we'll go back here for the, then from this point up to this point, so that will be 180 plus 30 of our actual angle, so that will be 210 degrees. And then for the last one, we have 60 newtons acting at an angle from this point up to this point, so that will be 360 minus 50 degrees. So we write down 310 degrees. So now we write down the x component and the y component for each force as long as we measure the angle as measured from the x-axis. So this will be 100 in cosine 45 for the x component, and the y component will be 100 sine 45. Then 80 cosine 150. Then for the y component, which will become 80 sine 150. Then 70 cosine 210. Then for the y component, 70 sine 210. And then 60 cosine 310 for the x component, and 60 sine 310 for the y component. So typing that in the scientific calculator, which would break down for the x and y components. So that will equals to this, and then we're gonna type in 100 and cosine 45. So that will become 70.7. Then same goes with the sine. Then we'll have the 80 cosine 150, which we would get negative 69.28, rounding off to negative 69.3, and the sine, which will become 40. For the 70 cosine 210, we get negative 60.6 for the x component and negative 35 for the y component. Then for the 60 cosine 310, we got 38.57, rounding off for the x component, and negative 46 for the y component. So now going back to the table, we can find the value of the sum of the x component by adding up the value of these four forces. So that will be negative 20.62. The units for this will be newtons, and we'll do the same thing for the y component of force. Now we'll find the value of the y component by adding up the four forces of the y component, which would become 29.74 newtons. Now that we've got the x component and the y component of our force, this will be the combined effect of those four forces acting on our system. And the next step is to now draw our diagram showing these forces. This indicates the y direction, and this is the x direction. Here, our x component is at negative, so it goes to the left hand side towards the negative x-axis. And then for the y component, going positive 29.74 upwards. And our resultant force will be the force that connects these two vectors together. So this will be our resultant force. And now we can find our resultant force using Pythagoras. So R will be equals to square root of negative 20.62 newtons squared plus 29.74 squared. And so the value that we get here will be equals to 36.2 newtons. We also need to find the angle at where this force acts. So that's this angle here, theta. Now, recalling from your basic trick, this will become the adjacent side, and this will be our opposite side. So now we can find the theta by using the tan rule. So theta is equal to the inverse tan of the opposite divided by adjacent side. So in the scientific calculator, this will become inverse tan over 29.74 over negative 20.62. Then we'll have 55.26 degrees. So my final answer for the resultant, we can write it down as follows. So the resultant vector is equal to 36.2 newtons, and as measured at an angle of as measured from the positive x-axis, which would become negative 55.26 degrees. And so that's how you find the resultant force from 4 forces.
Hi, it's me again, and I hope you learned something after watching this video. See you next time. Bye!